start objective 19 today. We are going to solve triangles using the law of cosines, okay? The goal here is we're going to start this today, do what we can, introduce it. That way we kind of have a foundation. Then when we come back, whatever day that may be next week, we can wrap it up and do some practice. Then we'll review and get close to taking a test on everything that we've done recently, okay? So, here's what we're going to talk about. I want you to solve each of those triangles using what you know. Okay, I want you to solve each of those triangles using what you know. So, can you use, first of all, our right triangles? Because have I told you these are right triangles? No. So you can't use the right triangles. Could you try to use the law of sines? So let me give you a minute to think about that. I want you to try to use the law of sines and tell me, because this is going to be the issue when we get to test day, is I'm going to give you a triangle and I'm going to say solve it, and I'm not going to tell you which law to use. Okay, or which method to use to solve it. So let me give you a minute to think about it. All right, so now that you've had time to think about this, here's my question. Can you solve these triangles using the law of sines? Why not? In order to use the law of sines, you have to have at least one angle and one opposite side, or corresponding side to that angle. And right here, we do not. So the question is, and we can't use the right triangles, so what do you do when you only have side, side, side? Or in this case, what do you do when you have side, angle, side? You have two sides and an angle, but none of them are corresponding. So there we're going to introduce the law of cosines. Okay, so you might just want to make a note on those triangles right there. We cannot solve those using the law of sines or right triangles because we don't have the information we need. Okay, so the law of cosines, and you're going to want to know on the test, when do I use the law of cosines? When you are given side, 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 or side, angle, side. Okay, and these are the three laws, and it just depends on, like, here's the question. If you're, notice all three formats, everybody take a look at this really quickly, and then I'll give you plenty of time to write this down. Do you see, like here, you've got A, B, and C. You've got A, B, and C. You've got A, B, and C. You've got all the sides on all three. So it depends on which angle you're looking for or which angle you're using as to, like, if I have angle A, then I'm going to be using this formula right here. Does that make sense? Or if I have all the sides and I'm searching for angle B, then I'm going to use the second one. Does that make sense? So the difference is going to be with which angle you're either using or searching for. Does that make sense? And that's going to be how you know which one to use. So I'm going to pause this and give you a second to copy these formulas down. Got it? Ready? Let's see it put into action. Okay, so just really quickly, the question was, is that a dash or a minus? This is a squared minus b squared plus c squared minus 2bc times the cosine of a. Okay, and I'll also, like, you know, if you're working on memorizing these, of course you got it on your formula sheet, it's on your colored sheet, but like, notice here, the one you're solving for, that's going to reciprocate the angle that you're using in that particular formula. And then, you know, if you're solving for the side of a squared, or the side of a, then you're going to use b squared plus c squared, but then when it's minus, notice it reuses bc that you just added together. Does that make sense? Yes, no, maybe so. Okay. So just a couple ways that I work to remember this, okay? So let's go ahead and draw this. I encourage you to label A, B, and C. And so the side opposite is going to be 5. The side opposite here is going to be 8. And the side opposite from C is going to be 12. Okay? And I want to solve the triangle. Now, in this case, I've been given side, 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 3 sides. And I want to start finding the angles. So which formula would I use, or would it matter? It's not going to matter. So pick an angle you want to solve for first. A. Okay, so which formula are we going to use if we're solving for angle A? The first one, second one, or the third one? The first one, okay, because that's the one that uses angle A. So it says A squared equals B squared plus C squared minus 2, now reuse BC times the cosine of angle A. And we're going to plug in and we're going to solve this. So A is equal to 5. So we're going to say 5 squared equals 8 squared plus 12 squared minus 2 times 8 times 12 times the cosine of A. And that's what we're going to solve for, is the cosine of A. Remember, you can only solve for one variable at a time. So if you plug in and you have 2 missing variables, then obviously you use the wrong formula. Okay? So what can we do? We're going to work this piece by piece. What can we do first? So you can solve the squared. So you could say 25 equals, let's go ahead, you can square those and add those together. I'll let you do all that together. So square 8, square 12, and add them together. Tell me what you get. 208? Okay, so 208 minus, go ahead and let's multiply 2 times 8 times 12 together. $192, thank you very much, times the cosine of A. Okay, so if I want to get A by itself, what am I going to do to solve for this? Can I subtract 208 minus 192, first of all? No. Why not? Because 192 is attached to the cosine of A. Does that make sense? So basically, we've got to take everything that is separate. 192 is with the cosine of A being multiplied. We got to take everything separate to the other side. So this is why I said you're going to have to be able to solve this piece by piece. So what do I need to move? I'm going to move the 208 over, and I'm going to subtract 208. So what's 25 minus 208? Negative 183. Okay. Equals negative 192 cosine of A. So how do I get rid of the negative 192? We're going to divide by negative 192 on both sides. Okay, and we're going to get a decimal. Read me the whole decimal. We're not going to round. 0.953, what? 125. That's it? Everybody agree? Okay. Equals the cosine of A. Okay, so now what do I do to solve for angle A? How do I get rid of the cosine? We're going to take the inverse cosine, or cosine to the negative 1 of this decimal, and when you multiply it over here, they will cancel. And so A is going to equal, got it to the nearest tenth? 17.6? All right, so our first angle is 17.6 degrees. Okay. Now where do we want to head? B? Okay. So we can use this. Now here, anybody want to ask me a question like Miss Corns? Now that we know one angle and one opposite side, what could we do? Okay, so here's what I'd like to do. I want you to do the law of sines. Let's see if this works. I'm on the board going to do the law of cosines. Does that make sense? And we're all going to find angle B. So I want you to use the law of sines now that you know one angle, and I'm going to use the law of cosines to find angle B and see if it comes out the same. Okay, so I want you to follow with me on what I did, okay? I was searching for angle B, and I had three sides, so I used our second formula that gives us angle B, okay? And I plugged in. Notice I multiplied, I went ahead and squared and added that part together, okay? Because they are separate, so I could go ahead and do that, and I got 169. Then I went ahead and multiplied negative 2 times 5 times 12, and I got negative 120. You cannot, number one mistake is people try to subtract 169 minus 120. But you cannot do that because the negative 120 is attached to the cosine of B. So instead, I moved the the 169 over and subtracted, and I got negative 105, and then I divided by negative 120, and I got 0.875 equals the cosine of B. And then to get rid of the cosine, I took the inverse cosine. And when I did that, I actually ended up with 28.955, which for me would round to 29.0. But here's what I'm going to say. Why did mine come out? Everybody else in the class, if you're following along with me, everybody else in the class did the law of sines. And I'm guessing they did the sine of 17.6 over 5 is equal to the sine of B over 8, right? And when you cross multiplied, everybody in the classroom came out with 28.9. And I came out with 28.95, which would round to 29. So here's what I'm going to say. Why is my answer slightly different? Because I use cosine. Does that make sense? If you're going to use different methods. So what's kind of my, unless we're doing it all specifically the same way, like the other day when we did our law, we were all using law of sines, all doing it the exact same way, and I took off points if you did not round correctly, right? But once we get into this, if you are in the ballpark, we were only like 100th off. Does that make sense? If you're in the ballpark, I will count it correctly. So which one do you want me to use, 29 or 28.9? 29 because you just like whole numbers. All right, and so here's my last question, putting it all together. So do you understand? Like once you find the first thing, I get it. Law of cosines is what? Lengthier. Yeah, it's longer, it's lengthier. You know, if you want to get good at it, you can solve every angle by the law of cosines. But if you wanted to, you could get your first angle, then use law of sines to get your second angle. What could I do to get my third angle? Add them together and subtract it from 180, so what's the third angle? What would it be? If we're using 29, what will it be? 130? 133.4? 133.4 degrees. Okay? Any questions about that? Okay? And then again, make sure your triangle, make sure it makes sense. Does the smallest side reflect the smallest angle? Does the largest side reflect the largest angle? Okay? So, let's take a peek at our second one. Okay? This is the one that actually you drew earlier. And you told me earlier you couldn't do it, but now you can, right? So I want you to take a minute, and can you start with the law of sines? No, you're going to have to use the law of cosines. So pick an angle, use your law of cosines, and then finish solving it out, and we'll see what we get. All right, so I'm going to solve. What do you want to solve for first? Did everybody solve for A first? All right, so we're going to use, if we're solving for angle A, then we're going to use A squared equals B squared plus C squared, not B squared, minus 2BC times the cosine of A. Okay, so A is equal to 2 squared equals 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of A. Okay, go ahead and square everything. So 4 equals, I'm going to square and add those. What do you get? 25. Minus, I'm going to go ahead and multiply those. You get 24 times the cosine of A. Again, do not subtract 25 minus 24. You cannot do that because the 24 is attached to the cosine of A. So you need to move this across, and you get negative 24 times the cosine of A. And so this becomes negative 21 equals negative 24 times the cosine of A. And then we're going to divide by negative 24 on both sides. And so what do we get? 0.21 divided by 24 is 875. And again, don't round that to 0.9, because if you round right now, what's that going to do to your answer? It's going to mess it up. So now take the inverse cosine, and what does A come out to equal? 29? Everybody agree? If you round it, 29. Okay. So that's A is going to be 20. A is going to be 29 degrees. Okay. So from there, my question is, you can choose. At this point in time, you can choose. You can continue to use the law of cosines, or you have enough information now that you could solve using the law of sines, which might be slightly easier. Okay. So what are we going to use? Okay. So what do you have? What does B come out to equal? 75.2. Okay. And what does C come out to equal? 75.8? That's not what you got. Okay, let's go back then. Let's get in agreement. Here for B, 46.7, and then C you get 104.3 degrees. Okay? Hear this. Okay. So do not forget what we did yesterday with our ambiguous cases, okay? So yes, we did law of cosines here, and we found that the first angle was 29 degrees. Great. But when you go back to the law of sines, you have to check for that second angle when you find the next angle. So we found option A, our angle is 46.7, right? Let's go to option B. We have the 29. Does that make sense? You got to use what you first found using law of cosines. Okay, that ambiguous case only comes from when you start the law of sines. Do you understand that? So when you do, if you want to make sure that you don't get that ambiguous case, do you understand what I'm saying? I just use law of cosines the whole way through. Does that make sense? But let's think about here. We knew that this was 3, this was 2, and this was 4. When we found this second angle, there is another option to that. What's the other option to 46.7? there are two places that the sign is positive, right? It goes back to your, give me a red pen here. They don't like red. Let's go yellow. There we go. It goes back to your coordinate grid. Your first one is here in quadrant 1. Everybody agree the sign is your y, and it's positive. If you're going up, it's positive. So it's positive in quadrant 1 and in quadrant 2. So how do I find that second possibility? What am I going to do with 46.7? Okay, subtract it from 180. What do you get? 133.3. And that would make the third angle what? 17.7. Okay. So that adds up, correct? But you gotta, there's only going to be one possibility here. First of all, ambiguous cases only happen when you use what? Law of sines. When you have two sides and an angle. Okay, side angle. You with me? Or side angle side, excuse me. Yes, it all adds up to be 180. That part makes sense. But what do I always ask at the very, very end of the question? Does your answer make sense? One of those triangles does not make sense. Why does the second one not make sense? Okay, exactly. So here, the smallest angle is opposite from the largest side. So yes, you have to check. So I just want to caution you, if you go from the law of cosines on your first, and then you head straight into using law of sines. When you go into that law of sines, does that make sense? And I get that first angle. Always subtract it from 180, and I'm going to tell you that this doesn't make sense, okay? Does that make sense? And really, in this case, I could have stopped right here because I knew that this answer did what? Made sense, okay? But so if you solve it using law of sines and your answer doesn't make sense with your three sides, if it's the smallest angle is not opposite the small side and the largest angle is not opposite the largest side, then you go and use the second triangle. Does that make sense? Just make sure your answer makes sense, because there's always that option when you're using two sides and an angle when you do law of sines. Do you understand that? Did I make that clear? Yes? Okay. Better than yesterday when I first introduced it? Okay. So I think we're going to stop on this one. What's my time? 10:29. All right, so go ahead and write this down. We'll use this as a warm-up for whenever we come back. So go ahead and write this down. And if you want to attempt it, you can attempt it. But we'll start with this one when we come back after the weekend.